Hello everyone. The headline of our lesson for today is symmetry of graph. What is the symmetry of graph? We have two kinds of graph symmetry. Symmetric with y-axis and symmetric with origin point. For the symmetric with y-axis, the graph is called to be symmetric with y-axis if the half, if we flip the half on the right y-axis to the half in the left y-axis, then the two halves match. If this condition satisfied on any graph, then we call this graph is symmetric with y-axis. For the symmetric graphically, for the symmetric with origin point, the graph is said to be symmetric with origin if we flip the upper part once by x-axis and one by y-axis, then the upper part match with the lower part. If this condition satisfied with any graph, then we say that the graph is symmetric with origin. Also, the graph is not necessary to be symmetric with y-axis or y-origin. The graph may not be symmetric, neither with y-axis nor with origin. Then we say the graph is neither. Not even, not odd. The graph that is, or the function that is symmetric with y-axis is called to be even function. And the function that is symmetric with the origin is said to be odd function. The function is neither if it is not odd or even, or it is not symmetric with y-axis or with x-axis. I'll give you some fast rule to find the function if it is odd or even. Mathematically, if we want to find the function if it is odd or even, if the function satisfied f of minus x equal to f of x, then this function is even. If the function satisfied the condition f of minus x equal minus f of x, then the function is odd. That's it. If the function didn't satisfy the first condition or the second condition, then the function is neither. The first rule to find the even and or odd function: even function plus or minus even function equal to even function. Odd function plus or minus odd function equal to odd function. Even plus or minus odd equal to neither. Even times even equal to even. Odd times odd equal to even. Even times odd equal to odd. Even over even, it's even. Even over odd, odd. Odd over even, it's also odd. Odd over odd is even. Absolute value even equal to even. Absolute value to odd also equal to even. Even plus or minus odd, absolute value, it's neither. Square root even, it's even. Square root odd, it's neither. Cube root of even, it's even. Cube root of odd, it's odd. Sine x is always odd. Cosine, it's even. Tan, it's odd since it's sine over cosine. Sine to the power n of x, it's even if n is even, and it's odd if n is odd. Tan x is also even. Tan to the power n of x is also even when n is even and odd when n is odd. But cosine to the power n of x is always even n either n it's even or odd. Every constant function is even. The zero function f of x equals 0, it's only the function that it is even and odd in the same time. Let us solve some problem. Find each of the following question is even or determine each of the following question is even or odd function. For the first function, f of x equal x power 2 times sine x power 2 is even, sine x is also odd, then even times odd equal to odd. Second function, odd plus even over odd plus odd, it's odd. For the third function, even minus even, square root even over odd, it's odd. For the fourth function, even minus odd plus even, neither, square root neither, minus even, it's neither. Number 5, odd plus even times odd plus odd, it's odd. Number 6, even times even minus odd, neither, plus even, it is neither. Number 7, odd minus even, neither, absolute value neither, plus even, it is neither. Number 8, even times odd plus odd times even, odd plus odd, it is odd. Number 9, even over absolute value odd, it's even over even plus even, it is even. Number 10, I need to simplify this function to find its symmetry. Determine analyze by y for these two terms, x power 2 plus 4 equal to 3x power 2 plus 1, then y equal to 3x power 2 plus 1 over x power 2 plus 4. Now, even times even plus even, it is even over even plus even, also even. The answer is even. For the number 11, odd times odd plus odd, absolute value odd is even times odd, cube root of odd, it's odd, odd over even, then it is odd. Question number 12, determine which of the following is even over odd. We complete. F of x equal absolute value x sine x power 2 over x power 2 plus 3. Absolute value odd, it's odd times sine power 2x when x is when the power is positive, then it is even. When it's the power is odd, it's the function, it's odd. Now it's even, then sine power 2x, it's even times even over even plus even. The answer is even function. Number 13, odd cube root of odd, it's odd plus even times odd plus odd, it is odd over Odd minus even, neither, then odd over neither, it is neither. Number 14, even plus square root. Even minus even, even. Square root even, even. Even plus even, it is even over. Odd minus even, neither, then it is neither. Number 15, sine for 2x, since 2 is even, then sine power 2x is also even, even over even plus even, the answer is even. Number 16, odd times even, it's odd over absolute value odd, it's even, odd over even, it is odd. Number 17, I can rewrite this function as x root with order 5 to the x power 7, since the order of the root is odd, then odd to the root of the order odd, the answer is odd. Number 18, also odd to the cube root, it is odd. Number 19, rewrite this as x power 4 to the cube root of the x power 4, even to the x power 4, it is even. The last one, even minus odd minus even, it is neither. Absolute value neither, it's neither, minus odd plus even, it is also neither, then neither minus neither, the answer is neither. Look at these two examples. They are not much our rules. If we uh, apply our rule on these two examples, we will see odd minus even, it is neither. Minus absolute value neither, minus neither, it's neither. The answer is neither. But also this one, odd minus even, it is neither. Absolute value neither, neither plus neither, it is neither. But if we solve it mathematically, we will find f of minus x equal to minus x minus a minus absolute value minus x plus a. Analyzed by minus x plus a minus x minus a, then equal to x plus a absolute value minus a plus or minus x minus a. Then this equal to minus f of x. Then the function is odd. If you multiply this function with minus, then it will be x plus a minus x minus a. Then this function is odd. For the second function, if we find f of minus x, it's equal to minus x minus a, absolute value, plus minus x plus a. Analyzed by minus, minus x plus a plus minus x minus a equal to x plus a absolute value plus x minus a equal to f of x. It's equal to x minus a plus x, so then it is even function. Then any function similar to this function, to these two functions, it is odd if the sign is negative and even if the sign is positive. Example, which of the following function satisfy this condition? F of minus x equal to minus f of x. This condition is for odd function. Then which of the following function is odd? Let me see. Odd times odd, it is even. Odd times even, it's odd. Odd over even, it is odd. Odd times even, it is neither. Then the right choice is B. Which of the following function is symmetric with origin and has two x-intercept as x equal negative positive 1? We know for the x-intercept we set y0 and solve to find x. If we set y0 here, then the x-intercept is square root 2 minus positive square root 2. If we set y equals 0 here, then this function has two x-intercept, negative positive 1, because the numerator is difference of 2 square. This is possible right choice. Also, this is possible right choice, but here this function has no x-intercept, since x power 2 plus 1 equals 0 has no real solution. Then I have number C, B or number C. Which of these two functions is symmetric with origin, is odd? Let me see. Even minus even over even, it is even. Let me see here. Even minus even, it is even. Even over odd, it is odd. Then number C is the right choice. Another example, if negative 1, 2, this point is on the graph of the symmetric function with y-axis. Which of the following point is also in the graph? We know when the graph is symmetric with y-axis, then when negative 1, 2 lay in the graph, 1, 2 it's also in the graph. The right choice is A. Why 1, 2? Because look at this graph. This is negative 1, 2. This is 1, 2. Then when negative 1, 2 lay in the graph, sure 1, 2 lay in the graph. Every point here, then the negative of it is it's also in the graph here. Another example, negative pi pi, it's on the graph x cosine x. Which of the points is also on the graph? Let me see this function. It's odd or even. Odd, x is odd. Cosine, it's even. Odd times even, it is odd function. Then when the function is odd, the point negative pi lay in the graph, then pi negative pi, it's also on the graph. Pi negative pi is choice number B. The rule is when the function is even, then only the sign of x coordinate which will change. But when the graph is odd or the function is odd, then the sign of two coordinates will change. Another examples, find the equation of the function that has two x-intercepts, x equal negative positive 1, and symmetry with y-axis. Then, the function that have two x-intercepts, x equal minus 1 and x equal negative 1, its numerator should be x power 2 minus 1. Since x power 2 minus 1, it's even, minus even, it's even, then I need even function in the denominator. Any even function you can write x power 2, then this is even function and has two x-intercept, x equal negative 1, x equal positive 1. Number 2, find the function that have two x-intercepts as negative positive 3 and symmetric with origin. Two x-intercepts are x minus 3, x plus 3. Then the numerator should be x power 2 minus 9. The denominator should be any odd function because the numerator is even minus even, even. And since the function here is symmetric with origin, should be odd, then I need odd function here. The odd function I can write sine x. Question or example number 3, find the function that has these three x-intercept, x minus 1, the bracket here is x positive 1, x equal minus 2, the bracket here is x positive 2 or x plus 2, x equal 4, then the bracket here x minus 4. Multiply these brackets to find the function. X power 2, x plus 2x, 3x, 1 times 2, 2. Multiply by x minus 4, x power 3, minus 4x power 2, plus 3x power 2, minus 12x, plus 2x, minus 8. Simplify, x power 3, minus 4x power 2, plus 3x power 2, minus x power 2, 12 minus 2, minus 10x, plus 8. This is our function. Example number 4, determine if the function is even or odd. Then let me open this bracket, 4x power 2 minus 12x plus 9 minus 5x. Simplify, 12 minus 5, 17x plus 9. Now, even times even, even, minus even times odd is odd, plus even, it is neither. Another example, find or determine whether each of the function is even or odd graphically. Graphically, I say if I flip the right half to the left half and the two halves match, then this graph is for even function. Now, if I flip the right half to the left half, the two halves it's matched, then this function is even. For the second graph, if I flip this upper half once by x-axis and once by y-axis, then the two halves it's matched, then this function is odd. Also, for the third graph, if I flip once by x-axis, one by y-axis, or one by y-axis, and by x-axis, the two half full match, then this graph is odd. For the fourth example, I see if I flip this half by y-axis, then the two half not match is not even, and if I flip it by x-axis and then by y-axis also not match, then it is neither. For this graph, I see if I flip it by x-axis then by y-axis, it is matched, then it is odd, and if I flip the right to the left by y-axis, the two half will match, then the graph is even. Another example, if the domain of the two function is -3 to 3, complete drawing these two function in both cases. If this function is even and this function is odd. To complete this function, the left half should match the right half when we flip it. Then I draw like this. This is our graph if this function is even and its domain from -3 to 3. For this function is odd and the domain is from -3 to 3, then the two halves should match if I flip it once by x-axis and one by y-axis. Then this is the left half. If I flip it by x-axis, then by y-axis, the two halves will match. The last example, if the function f of x is odd and this table is for the function, some point for the function, find f of 2 plus f of -4. I don't have the value of 2 and of -2, but I know that the function is odd, and since it is odd and the point -2 64 is on the graph, then the function 2 minus 64 it's also belong to the graph of the function. Since f of 4 is -80 and it's on the graph, then f of -4 it's 80 since the function is odd. Now I have f of 2, it is minus 64, and f of -4 it's 80. Negative 64 plus 80 is 16. The right choice is B.